So I want to talk sort of how can we tackle any rational function graph, okay? We talked about in the first lesson, we saw graphs, they generally look like this. And then there's usually a vertical asymptote, and there's a horizontal asymptote. It doesn't have to be on the axes, it could shift around, okay? But the graph generally looked like that. The other examples that I didn't do in 11.1 were just sort of special cases where the graphs are a little different, okay? But we can actually use what we learned here to figure those out as well. One thing that could happen, okay? Or sorry, I'll start again. We saw in the previous lesson, we got vertical asymptotes. Okay. How do we find the vertical asymptotes? We find the non-permissible values. Those are the values of x that make the denominator 0. Okay. So like if I said, what's the vertical asymptote? X equals 5. That's it. Okay. Don't overthink it. 0. Like what value of x will make the denominator 0? 0 here. It's because 0 squared is still 0. Okay. However, depending on the rational function, we might be able to do some canceling. And if you can do some canceling, it will take out the vertical asymptote and replace it with the informal word would be pole. The fancy word or phrase would be point of discontinuity. What happens that a whole results? We can cancel out a denominator. It no longer is a vertical asymptote, it becomes a whole. So here as an example, I want to sketch this graph, okay? First thing, whenever you see a graph that can be factored, do so. Top and bottom. Now, normally I would look at this, I would get my vertical asymptote, I'd get my horizontal asymptote, I'd get a couple of points and plot the graph. Okay, but there's something I can do here. One would think that the vertical asymptote is x equals 3. Okay, but I can cancel it out. So if I can cancel out the denominator, it no longer becomes a vertical asymptote, it becomes a whole at x equals 3. And what is the resulting function that's left? Y equals x minus 2, right? Well, what's that when I graph it? You got to go back to grade 10. That's a line. And we use y equals mx plus b. So b, or the y-intercept of this is what? -2. M, or the slope, is the number in front, 1. But remember, slope, we always think rise over run, so we do write it as a fraction. So what am I going to do? I'm going to graph this line, but wherever x is 3 on the line, I'm going to put a hole. So y-intercept is -2. Plot, use the slope to count out the second line. Slope tells me to go up 1 to the right 1. And my line's going to look like this. But remember, when I hit x equals 3, here's x equals 2. Here's where x is going to be 3. I put a hole there, a hollowed circle. I'm going to make that a little more obvious. And it's going to look like that. Okay? So whenever you can cancel out a denominator, you're going to get a hole. All right, similar question. This we don't have to graph them, but I want to see what's the difference between these two. Well, first of all, to figure out what's happening in vertical asymptote or holes, factor. What is the top factor to? X times x minus 2, and the bottom?
2 x minus 2.
So notice, normally we would say it's a vertical asymptote, but these cancel. So if there's not a vertical asymptote at x equals 2, there's a hole at x equals 2. For this one, which I factor, I get this, and the bottom is the same. Notice I can't cancel out a denominator. So that means if this is still a non-permissible value, it's just now it's a vertical asymptote. Okay, a hole happens when you can cancel it out with a numerator. So you have to keep that in mind when we graph these things. What's the other thing we have to keep in mind? The horizontal asymptote. Here's the general rule for horizontal asymptotes. Okay, and it's this here. We've already talked about vertical, but this is horizontal. What you do is you look at the degree of the numerator and denominator. What is the degree? The highest exponent. So if I said this, if I gave you this, you have to write this down. What is the degree of the numerator?
4.
The highest exponent, 3. What is the degree of the denominator? 2. Okay. What is the degree of the denominator? What is the degree of the denominator? Nothing. 0. Good. Okay. So 3 things happen. And the one we've done, if the degree of the numerator is less than that of the denominator, always y equals 0. Or the x-axis. Always. If the degrees are the same, take the numbers in front of those exponents and divide them. And that gives you your horizontal asymptote. So for example, if I said this, Here, the degrees are the same, right? Divide the numbers in front. So it'd be 3 divided 2 or 1.5, or you could leave it as 3/2. That's it. This was 4. 4 divided 2 would be y equals 2. So the horizontal would move up to y equals 2. If the degree is greater up top than on the bottom, there is no horizontal asymptote. So you have to remember those 3 things for the horizontal asymptote. That's what all this says. So what I want to do is practice with, before we do a couple of graphs, I want to practice with some rational functions. And don't be surprised if you see a very similar question like this in tomorrow's exam. Okay. So I want to know, we're only talking about the asymptotes. So I want to know if there's a vertical asymptote, and or a hole, and I want to know the horizontal asymptote. Remember, if you can factor, do so. Horizontal asymptote. What's the degree of the numerator? 1. So degree numerator. Is it less than, equal, or greater than? Less than degree denominator. Automatic. Y equals 0. Okay, so to get the horizontal, you got to look at the free factoring. Vertical, you got to look at the factoring. Can I cancel out any denominators or any of the expressions? Nope. So they're all vertical asymptotes. At x equals 3 and -3, and that's it. We're done. Can I factor anything in B?
No.
Nope. So horizontal. What's the degree of the numerator? 1. That's less than the degree of the denominator. So y equals 0. What value of x makes the denominator 0? One? Well, 1 squared is 1 plus 1 is 2. Nothing. You can't get it. You can't get 0. Okay? Because no matter what you put in here, you're going to square it and get a positive number. And then you're going to add to it. So there's no way you can get 0. So no vertical asymptote. This one, I'm not supposed to deal with the horizontal before I factor it. Degree of numerator?
1.
And less than the degree of the denominator, so y equals 0. Okay. To get to the vertical, you have to factor. It is a difference of squares that I can factor. What happens?
A whole.
A whole at where? Not plus 4. A whole at whatever makes this 0, -4. So there's a whole at x equals -4 because I can cancel those, but there's still a vertical asymptote at x equals 4. E can't do any factoring. Let's get the horizontal. Well, what's the degree of the numerator?
1.
A 1 and denominator. So if they're the same, that means I have to divide the numbers in front of those variables, those exponents. So 4 divided by 1. I'm not going to put the equal, I'm going to put it like this. Y equals 4 divided by 1, which is 4. Vertical, I can't cancel, so there's no holes. Just the vertical asymptote at, say it properly,
X2
x2,
equals 2.
x equals 2.
Okay, I want you to get used to these things because the last step is going to be graphing. And you are going to see some of this tomorrow. Not a lot, because it's not a very big unit. Horizontal asymptote. What's the degree of the numerator? Yeah, and the denominator. So because, I should have written this on the last one, because degree of numerator equals degree denominator, we divide 1y will equal the number in front of the x squared up top over the number in front of the x squared on the bottom. Y equals 1. For vertical, I need everything factored that I can. I can factor the bottom. Can I do any canceling? No. What are the vertical asymptote or asymptotes? X equals 1 and negative 1. Good. What's the horizontal?
3 divided by 1.
3 divided by 1 because the degrees are the same. And remember, it's y equals 3 divided by 1, which is 3.
Vertical. What value of x makes the denominator 0? Nothing.
So no vertical asymptote, no hole. This one. Horizontal. What's the degree of the numerator and denominator? So that means the degree of the numerator is greater than the degree of the denominator. What does that mean? Yeah. No horizontal asymptote. Factor. I can factor the top.
I know it's going to be -4, but is it a whole or a vertical asymptote?
A hole because it cancels. So there is a hole at x equals -4. How about h? Horizontal?
No.
None. Because the degree of the numerator is greater than the degree of the denominator. Can I factor anything? Nope.
X equals 1.
And is that a hole, a vertical asymptote? That's a vertical asymptote, x equals 1.
Okay. So what we want to do is we want to take this information and use it to graph these bad boys. So let's just do a couple of examples. And really, you don't even have to find all this stuff. This is to graph these things, this is what you need. You need these two, or sorry, because there might be a hole. You need to address these. And these. These are helpful, but they're not necessary to graph. And you could be asked, you may be asked, like, find the y-intercept of this. Well, that's easy. You just plug x equals 0 in and figure it out. Okay? But these are what we need. So here we have this one. The horizontal asymptote. That's where we do degree, degree. Yeah, so because the degrees are the same, I divide the numbers in front, 2 over 1, so y equals 2. So right away, I've got this. And that's going to give you something right away. Vertical asymptote. Factoring? No. So vertical should be pretty straightforward. And graphic. Vertical line at -2. Okay. Now, we have an idea of the shape. Like it's probably something like this. Or maybe it's the other way around. Who knows? In order to help me know that, I need some points. What you do, and I talked about this last year, pick x values, like you're going to do like a mini table. So here, I'm just going to put this y equals 2. X equals -2. There's no hole. So other points, I'm going to do this. I'm going to pick numbers on either side of these. One less, one more. So one less, -3. One more, -1. And I'm going to plug them in and calculate y. So here, I'm going to do 2 times -3 plus 3 over -3 plus 2. So that gives me -6 plus 3 is -3, -1, so it gives me +3. So that's a point on our graph. Do the same thing except plug in -1. One. Plot those points. So -3, 3, -1, 1. And remember, your curves go along the asymptotes. For the other information, like I said, for the y-intercept, you got to make x equals 0. And therefore, y is going to be 2 times 0 plus 3 over 0 plus 2. No. Yes? Yeah, 0 plus 2. So it's going to be 3/2.
which makes sense. Because if you look, I mean, I didn't obviously draw it perfectly, but I should be somewhere between 1 and 2 on my y-intercept.
And it is actually 1.5.
For the x-intercept, you make y equals 0. So we're going to solve this. 0 equals 2x plus 3 over x plus 2. Well, to solve for x, first of all, get rid of the fraction by multiplying both sides by x plus 2. And x plus 2 times 0 is 0. These cancel out, and I'm left with 2x plus 3. Move the 3 over, divide by 2. The x-intercept is going to be negative 1.5.
Which you can see according to my graph is about right. It could be asked the domain and range. Remember, this is where we use the not equal. With rational functions, use the not equal.
So for example, the domain goes left forever, goes right forever, but there's one value of x it can't be. Right here, the asymptote. So x cannot be. It's -2. Range goes down forever, goes up forever, except it can't be here when y is 2. So y cannot be 2.
Notice it's the same as the asymptotes, except we put not equal instead of equal. Okay. Last one. Horizontal asymptote, y equals 0, because the degree of the numerator is less than the degree of the denominator. Vertical asymptote / pole. Well, looks like I can factor the bottom. Like so. I can take these out, right? So there's a hole at x equals 2, and there's a vertical asymptote at x equals 3. And what am I left with? Well, this is just 1 over x minus 3. So I have the graph 1 over x minus 3. And then keep in mind when I sketch it to put a hole where x is 2. Again, you could do the y-intercept and x-intercept. I'm not going to worry about that. Okay.
Okay. So let's see.
We got y equals 0, x equals 3. I know there's a hole where x is 2, but I don't know where x is 2 right now. So I need some points.
And remember, pick points on either side of the vertical asymptote. So for your little table, pick 2 and 4.
Right? Because those are the numbers on either side of 3.
If I plug 2 in, I get 1 over 2 minus 3, which is -1. If I plug 4 in, I get 1 over 4 minus 3, which is 1. So 4, 1, 2, -1. So that means my graph goes like this. But I'm not 100% correct. Where is the hole? Guess what? We actually found it. Right? So this point here should be a hole. Okay.